Hello students, today we are going to start our unit 2 in and we are going to see what are the important things that we have discussed in unit 1 before going to start unit 2. So in unit 1 first we have discussed some key terms like alphabets, strings, language and how we are going to form a language by using a grammar. So these are the basic things that we have discussed. Then we have discussed two machines that accepts these regular languages. So what are those machines? Yes, you are correct. The finite state machines called as NFA and DFA. DFA in the sense deterministic finite automata and NFA in the sense non-deterministic finite automata. So after that, how we have discussed how to convert or design an NFA or DFA. After discussing these two important topics, we have switched over to the next one called as epsilon NFA. That means for a null value, how the transition is going to be made. After that, we have discussed how to reduce this epsilon NFA into normal NFA. Then we have discussed the important topic called as minimizing the DFA. Minimization of DFA in the sense we are going to minimize the states in the DFA. So obviously we know for a particular problem we may have come up with 4 or 5 solutions or even sometimes more solutions. But the finding the optimized solution plays the key role in discussing of NFA. So we know that NFA or DFA will be minimized and mostly we are doing minimization of DFA. So how I can reduce the states in an DFA is the important factor. So after minimizing DFA we have seen how to convert an epsilon NFA into an DFA, NFA and NFA to DFA. So these are all the topics that we have discussed in unit 1. In unit 2 we are going to dive deep into the concept called as regular expression and regular languages. So introduction. Regular expression is a symbolic notation used to represent a regular language. So instead of writing the regular language will be mostly expressed as a text or a string or group of words, whereas regular expression they are telling that it's going to be represented by group of a symbolic notations. Regular languages are sets of strings denoted over an alphabet, and regular expression provide a compact and regular algebraic way of describing themselves. That means the language is going to be represented in the form of algebraic fashion. Then we are going to call it as a regular expression. For the example, if the alphabet is A comma B, then the expression can be A plus B. Here plus denotes the union operations of the language. The construction of a regular expression is based on the few basic rules. The empty string is represented by epsilon as we discussed in the earlier unit, and the single alphabetic symbols like A or B represents a string containing just a symbol, and the empty set is denoted by phi. Beyond these basics, the operation is allowed to build on complex expressions are. So we have few number of operations, but the important operation that we are going to perform are union, concatenation and clean star. The union is denoted by plus symbols, allows the alternation of concentration places two explanations and is a sequence, and the clean star allows for representation of patterns 0 or more times. For instance, the expression A plus B star AB represents set of all strings with substring AB over the alphabet A comma B. Some strings include AB, AAB, BAB, ABAB and so on. The demonstration of regular expression power of regular expression is defining infinite consistently. The basic rules of regular expressions are for sigma A comma B, epsilon is represented empty string, A represents a string which is just A, B represents only a state B, phi represents an empty set. The operations are, as we discussed earlier, union, and we are going to see some lemma or theorem or conclusion about these operations. First one, union. If R1 and R2 are regular expression, then R1 plus R2 denotes the union of languages. For example, A plus B tends to A comma B. And concatenation. If R1 and R2 are regular expression, Then R1, R2 denotes concatenation. For example, AB represents AB. Clean star. If R is a regular expression, then R star denotes 0 or more repetitions of R. For example, A star will be represented as a set epsilon, comma A, comma AA, comma AAA, and so on. It is an infinite state. So regular expression and languages. So what are the basic difference? Set of vowels we have represented as hyphen, bracket and a. Regular languages e. A followed by 0 or more b will be represented as ab star, whereas in regular language a comma ab comma ab likewise it goes on. Any number of vowels followed by any number of constants a e I o u star, after that b c d to z star. That means any number of vowels can be followed by any number of stars, and it can be represented as language is represented as epsilon a aoe aioe b and abcd. Likewise it can be go on. And then regular grammar. A regular grammar is a formal grammar that generates regular expressions or regular languages. Terminal symbols we have already discussed about the regular grammar: terminal, non-terminal, production, and then start symbol. So this thing is same as in the first unit. And then types of grammar. So that we didn't discuss in the unit one. So types of grammar. So we are going to call the right linear grammar and left linear grammar. So look at the example here. S tends to small a, capital S. Here the terminal symbol is followed by a non-terminal symbol. That means the non-terminal symbol is right side of the terminal symbol. Then we are going to call it as a right linear grammar. So likewise for left linear grammar, A tends to A or A tends to B A. That means A, capital A tends to capital B A. Look at this example here. Here the non-terminal symbol is left side of the terminal symbol A. So this is a left linear grammar. So very simple, students. If the terminal symbol is right side to the non-terminal symbol, then it is a right linear grammar. If the terminal symbol is left side to the non-terminal symbol, then it is a left linear grammar. Regular languages and its properties. So it is same as the properties of regular expression. So we can also call it as a closure properties. So here we are going to discuss about union. So union in the sense, that time we have seen R1 and R2 are regular expression, then R1 plus R2 will be a regular expression. Here we are going to see if L1 and L2 are regular languages, then union of L1 and L2 will also be a regular language. Likewise intersection, if L1 and L2 are regular languages, then the intersection of L1 and L2 will also be a regular expression. And the third one is concatenation. If L1 and L2 are regular languages, then the concatenation will also provide a regular language. And the next one is clean star. Here, if L1 is a regular language, then clean star of L1 will also be a regular language. Complement. If L of G is a regular language, then the complement will be L dash of G will also be a regular language. So these are all the few examples or closure properties. Next, finite automata. Every regular language can be recognized by a finite automata. This we know. That means regular language or a regular expression, it is definitely will be recognized by a finite state machine, and that finite state machine can be either DFA or NFA. So decision problems where we can use these finite automata machines or these regular expression. Problems like membership testing, empties and equivalence can be solved using regular languages. Note, two regular expressions are equivalent if language generated by them are equivalent. For example, a plus b the whole star generates the same language. Every string which is generated by a plus b the whole star is also generated by a plus b the whole star. The comparison table. So definition, representation and use cases are the aspects that we are going to compare the regular expression, grammar and languages. So whereas for the definition, regular expression is a pattern or representing of strings. The grammar, rule based generation of strings. Language, class described by regex and grammar. Representation, symbols and operators, terminals, non-terminal symbols and production rules, and finite automata, regex or grammar. Use cases, text processing or validation by regular expression, syntax generation for compilers, and the last one is language recording. And the next thing is finite automata equivalence with regular expressions. So how the finite automata is going to be equated with the finite regular expression. Finite automata and regular expressions are two ways for representing patterns in strings with formal language theory. While finite automata uses states and transition, regular expression provides compact symbolic notation. Converting a finite automata into regular expressions helps to understand their equivalence, and it's useful in the fields of computer design and texting. What are the states I have to use is, first one method is state elimination method. If the initial state is either an accepting state or incoming transition, introduce a non-accepting state. That means start state will be replaced by a non-accepting state, and then add epsilon states from new start and to the original start state. If there are multiple acceptance states, or if a single acceptance state has outgoing transition, create new acceptance states, change all other accepting states to non-accepting states. Same epsilon transition from former accepting state to new accepting state. So it states that both initial state and final state will be formally removed, or it can be started from a new state. For each state that is either start or non-accepting state, eliminate the state and update the transition according to maintain the function of the automata. So in this example, look at the start state. One is the start state, and then D is the last state. So here we are going to remove the 1 and remove the final 4, and we are going to convert it to a new state. That means uh, 0 will be the start state, new start state. For epsilon it goes to 1, and also 4 will be moved to the 5, and it is going to be the new start state. In steps 2, we are going to eliminate each state. That we are going to, for example, if I am going to eliminate state 2, I am going to look it out what are the input states coming to 2 and what are the output gates going to 2. So for input we are having AA, and output we are having AB plus epsilon. So by removing the 2 from the diagram, it's going to look like in the step 3. From 0, instead of 2, we can directly reach to 3 by using the following regular expression: b plus a star into ab plus epsilon. In the step 4, we have reduced another state called as 3. So these are the ways that we can reach the state 4 and 5 via 0 without the states 2 and 3. And the fifth step, we have eliminated the fourth step also. That means from 0 to fifth state. So while looking this exam, we understood that we eliminate all the intermediate state except the new states that are introduced by the us. That means we introduce two new states here. One is 0 by replacing the starting state 1, and another one is 5 by replacing the accepting state 4. So from the new introduced start state to the new introduced acceptance states, what are all the regular expression that we have discussed, and the values are like b plus a into a star ab epsilon plus b star b plus a star ab plus epsilon into b star b a plus a star ab plus epsilon b star epsilon plus a into a star into ab plus epsilon into b star. So this is the overall regular expression for the given diagram. Thank you, students. I hope you have understood this topic. Thank you.